kids' grades off of there. I will do 1 through 5, and then I will assign 6 through 12. So, not quite half will I do with you. 1 through 5, 6 through 12. Trying to figure out how many 6 through 12 is? I think it lands on 7. Right? Because there's 12 total, and I'm doing 5 of them. That leaves 7. You could even use your calculator for that if you need it.
I had enough fingers for this.
Okay, good. You must draw a picture, define the variable, write the equation, and solve the problem algebraically or graphically. So that would mean with the calculator. Graphically with calculator. Find all solutions. If only one solution is used for the answer, explain why the others are not valid answers to the problem. Round to the nearest thousandth if necessary. I can tell you right now the invalid answers will likely be the negative ones. So if we get something like that, and we're trying to find the length of a box or something, well, you can't have a negative length. That doesn't make sense. So a lot of times we'll get some answers that don't really make sense. So that's what it means when it says, if only one solution is used for your answer, explain why the others are not. And it will usually be because there's a negative dimension. So you think about, if you want to construct a box that's -3 inches by -4 inches, you can't do that. So mathematically you get an answer, but that doesn't really make sense. That's what that's talking about. Okay, number 1. A storage company, and back up before we even get started. Some of you are really going to like these because they're kind of puzzle problems. You got to figure them out a little bit. They require thought. Others of you are going to shut down because you don't do thought. You want to process. You want an algorithm for everything. Like, just teach me what to do. I don't want to think. Just teach me what to do. That won't work today. Like, you got to think about what's going on. And so if you're a disengage the brain person and just check out and just teach me the process, there's not a process. There is only thinking about what they give you. So, again, some of you will enjoy these because they kind of make your brain think, and others of you, you're going to see the words and be like, oh, I can't do that. That's not true. You can, but you'll have to turn the brain on today. All right, number 1. A storage company needs to design a new storage box that has twice the volume of its largest box. Its largest box is 5 feet long, 4 feet wide, 3 feet high. The new box must be formed by increasing each dimension by the same amount. Find the increase in dimension. Okay, so the old box is 5 by 4 by 3. So that means its volume is 60. 5 times 4 is 20, times 3 is 60. That's the old box. The new box needs to have what volume? 120. Twice the volume. So the new box needs to equal 120. The volume needs to equal 120 because we're going to double the size of this box. And for whatever reason, they want to take the 5, 4, 3 dimensions and increase each of them by the same amount. So length times width times height to get volume. If the old length was 5, what's the new length going to be? If I want to increase it by some amount. 5 plus x. And if the old width was 4, and I want to increase it by the same amount as I increase the length, 4 plus x. And height was 3, so 3 plus x. So all of that needs to be 120. I need to go back just a second and say that, define the variable. So I need to say what does x represent in my problem here? The amount that's added, the increase in dimension, either of those is fine. Amount that's added, one way to say that. It's the increase in dimension. And maybe that's obvious for this one, but sometimes you get working in these and you get down to x equals 12 and you're like, aha, my answer is 12. And maybe not. This one asks for the increase in each dimension, so we're finding x. It could have easily asked for the new dimensions, and then we would have to do something with x. Okay, so how do you want to solve 5 plus x times 4 plus x times 3 plus x equals 120? We could distribute it. Meh.
I just plugged in
Plugged in 1, 2, and 3? But the x has got to be the same. You mean you plugged in x for 1, see if it worked, plugged in 2, see if it worked, plugged in 3, see if it worked? Did one of those work?
Yeah.
Well, shame on us for making that problem too easy. Let's find a way that we'll use the calculator. So I'm not even going to multiply it out. I'm going to leave it as 5 plus x, 4 plus x, 3 plus x. And on the calculator, I could graph that and 120 and see where they intersect. But it might be easier to move the 120 over so that then I'm finding zeros, because finding zeros is usually easier. Let's see. Again, I'm not worried about distributing, because I'll let the calculator handle that. 5 plus x, 4 plus x, 3 plus x, minus 120. And I want to know where that equals 0. We'll just start with Zoom standard and see if that's good enough. Well, it looks like there's one answer, and it's positive. Table first, maybe? Yep, x equals 1. This one had a nice answer. Easy enough to check, because my new volume would be 6 times 5 times 4, and that's 120. So if we increase each dimension by 1 foot, we get a box that's double the original volume.
Can you explain how you put it in the calculator?
Yeah, so in the calculator, I put in this for y1. And I did not multiply it out. I just left it in there, let the calculator handle that.
And then you look for the 0.
And then I looked for the 0. Find the zeros, because there might have been more than one solution. It doesn't make sense that this one would have been more than one solution, because if we added more than one, then our volume just keeps going up. If we add less than one, our volume keeps going down. So it doesn't make sense that there'd be more than one solution for this problem. Big issue in calculus, anyway, is to go back and make sure we answered the right question. Find the increase in each dimension. We did that. Number 2. An open box is made from a square piece of material with a side length of 10 inches by cutting equal squares from the corners and turning up the sides. Okay, let's see if you can picture what's going on here. So there's my square piece, 10 by 10. And if I cut a square from each side, and I fold up the corners, then you might see where that makes a box. This is a common problem in calculus, which is why I have my ever handy, it's not a square to start with, but I did cut a square from each corner, and if you fold up the edges, then we have a box. So that's the picture of what's going on. We take this 2D piece of metal, and we cut the corners up, fold it up, and now we got a box. What size of square would you cut out if the volume of the box must be 48 cubic inches? Okay, so we've got to cut squares out for this to line up. So all of those dimensions are x. All of those little dimensions are x. That's labeled on my physical model here. Those are x. Fold them up, and you can see that becomes the height of the box. So I want the volume to be 48. So that's length times width times height is 48. Okay, now can we figure out what those dimensions are? I think one of the dimensions is easy. The height is going to be x. And if we fold this up, our height becomes x. Thank you. What about the length of this box?
10 minus 2x.
10 minus 2x. It was 10, but we cut an x off of each end. And so this length is missing the 2x's, so 10 minus 2x.
The width is the same.
And the width is the same since we started with the square. 10 minus 2x times 10 minus 2x times x is supposed to equal 48. So again, you could put one of those in for y1 and one of those in for y2 and look to see where they intersect. But then you have to be playing with your window to figure out, well, how high is 48 and where does it... It's much easier to just move the 48 over. And again, since we're using the calculator, we don't need to multiply all that out. We can let the calculator do that. I mean, why risk making a mistake? Let the calculator handle it. I could even go fancy here. What could I do instead of 10 minus 2x times 10 minus 2x?
10 minus 2x
Squared.
Except to put in an error in the calculator. Just you.
That makes an error?
Oh, my calculator.
I don't think so. I'd go back and look and see if you typed something in wrong. So 10 minus 2x squared times x minus 48. I want to know where that equals 0.
There's 3.
Oh, there's 3 spots. Okay. So maybe there's 3 possible answers. I don't know. I guess if you cut out a small little piece, the volume would be small. If you cut out too big a piece, the volume might be small, but it might be tall. So I don't know. Let's figure out what these are.
Oh, yeah, there's 3 dimensions.
And backing up, I definitely know there's 3 zeros because this was an x cubed problem. So I don't know if all 3 zeros actually work, but let's figure this out. I guess we could go table first to see if any of them are easy.
Yes, 3, 1.
Yes, we got one easy one. X equals 3. Let's see, I don't know which one that is. It's the middle one. So that's 3, so that was an easy one. Second calc 0. See if I can find my cursor. Oh, there it went. You can't see everything, so if you don't like that, you can change your window. Like if you want to look a little lower and a little higher to see what's going on. Whoops. That would be on the Y's, not on the X's. Maybe that helps. Second calc 0. Let's see. Left bound, right bound, guess. So 0.628. We want 3 decimal places. 3 we already have, and whatever that other one is.
6.37.
Left bound, right bound, guess. 6.372. Okay, the question was, what size square would you cut out the volume? Okay, so X is what we're looking for. So does this mean there are 3 answers to this question?
Yes.
All right, well, look carefully what would happen. If we cut out 0.628 from each side, that's fine. That's just going to be like almost similar to this, a pretty shallow box. So that works. If we cut out 3 from each side, oh, now we better be careful. How much left is if we cut out 3 from each side?
4.
3, 4. Yeah, that's okay. That'll be like a taller box, but I guess a volume of 48, so that's fine. And then what happens if you cut 6.37 from each side?
No more box.
No more box. It's like have negative height and width, and that's actually why the math works, because if you have a negative height or negative width and a negative length, somehow negative times negative is positive, and your calculator doesn't really get that. But we can see that, wait a minute, that leads to no more box. So there's two legitimate options and one fake option. Yeah, I don't want to use the word imaginary because that has a different math meaning, but fake option is a good enough word for it. Nicole?
Aren't you looking for like the area of a whole square, not just a little side?
Well, because of what it asks, what size of square? It didn't say area of square, so I guess we can say 0.628 by 0.628 or 3 by 3. You're right. We should be a little more careful in how we answer that question. And size of square is maybe not as clear as it should be. It doesn't say area of square, though. Yeah, 6.37. Mathematically, yes, but good luck cutting 6 inches from each side of this 10-inch square. Let's see, did we do everything? It said label your, define the variable. I think a picture with X labeled, I'm going to say that's defining the variable. I don't think you need to write out what that stands for if it's labeled in the picture. I think we're okay there. Number 3. Several popular models of carry-on luggage have a length 10 inches greater than their depth. To comply with airline regulations, the sum of the length, width, and depth may not exceed 40 inches. Okay, we'll start writing this stuff down. So length plus width plus depth has to be less than 40 inches.
Must be less than or can be less than or equal to?
Cannot exceed, so I guess we should say less than or equal to. I don't know if that's really going to matter for the rest of the problem, but you're right, it should be less than or equal to. And then the length is 10 inches greater than the depth. So the length is depth plus 10. Write a function v of x to represent the volume of the luggage. Well, I don't know that I can jump straight there. So not v of x just yet, but volume is going to be length times width times depth. And I think we could solve for D or L, I guess either one. Well, we already solved for L, so let's just leave that. So length, we can just leave as length. Width, I don't know yet. Oops, I'm doing that wrong. Let's replace L with D plus 10. All right, that's an easy substitution. Kind of handed that one to us. L is the same as D plus 10. But we could also use that same substitution on this 40-inch equation up here. So I could replace L with D plus 10. So D plus 10 plus W plus D. And if we really want to maximize, which I assume we're about to do, maximize this, then I'm just going to set it equal to 40. Right, because I want my dimensions to be as big as possible to maximize. Anything less than that will fit, but I want as big as volume as possible. So now let's clean this equation up. 2D plus W equals 30. And looking at my volume equation, what would be wise to solve for, do you think?
W.
Yeah, let's replace W. I guess you could replace D, but you'd have to replace it twice, and that would make things a little uglier. So let's solve this one for W. 30 minus 2D. And so W is 30 minus 2D, means I can replace W with 30 minus 2D. D plus 10, 30 minus 2D, and D. So now I have volume as a function of depth. I've got volume as a function of one variable. So now I can go to the calculator. What are the dimensions of the luggage that would achieve the maximum volume? So how am I going to look for maximum volume on a calculator? Yeah, the peak. So let's put in this equation and look for the peak of that equation. And again, take the time to multiply it out if you like, but why would you bother? Yeah, we'll just use x. X plus 10, 30 minus 2x, and x. And looking for the peak means we'll be looking for the top, so who knows how far up this thing goes. Uh-oh. Well, I'm not seeing anything there. I might need to expand my x window. I don't really need to expand it in the negatives, because if D is negative, that's not going to make any sense. That's like the box that we destroyed earlier. I can't have a negative depth, so I don't really care how far negative we go with the x's. 20. We certainly, I don't think we'd go any farther than 40. I guess let's go out to 20 and see what it looks like. Okay, well, I see something. I think I need to change my y, min, and max, because I'm looking for a volume where my numbers, I assume, are like 10, 10, and 20, or something like that. Because I have to add the 40. So 10 times 10 is 100, times 20 is 2,000. Did you see anything if you change it to 1,000? Oops, I don't care about y min being 1,000. Let's go y max 2,000. That might be overkill, but we'll see. Oh, there we go. We're getting there. 2,000 wasn't quite enough, but almost there. 2,500 might be enough. And again, I don't care about my y min, because that's like negative volume. That doesn't even make sense. I don't care about x min, because that's the depth. I can't have a negative depth. So I'm looking for that maximum volume. So second calc. This time we want to find the maximum. Left bound, right bound, guess. Now let's be careful here. What does x in my calculator represent in my paper on my problem? Yeah, so x is d. That's 8.931. And what did y represent in my... Y in my calculator is what in my problem?
I don't even know.
This is what we put in for y1. That's the volume. So y is the volume. 2052.205. And then let's make sure we answer the right question. What did you say, Jack?
I think that 2,000 something, that's the value. It's a little bit more than 40.
Well, the 40 wasn't the volume. The 40 was the sum of the dimensions. So we're okay with that.
So we need to find three things that add to 40 to give us.
What are the dimensions? Well, we found the depth dimension. They gave us that, or the calculator told us that. And now we need to find the other two dimensions.
Which is just adding 10 or subtracting.
Yep, we've got a formula. In fact, I accidentally highlighted it. Length is d plus 10. So that's an easy one. 18.931. Stick with our color code here if we want. And then how could we find the... There's a couple ways to find the width. We got a formula for width. But it also should be... Like they're supposed to all three add to 40, so I could just subtract those from 40. I think either way would work. 30 minus 2 times 0.931. How did you get 12.138? Did you subtract from 40? Okay. So one person subtracted from 40 to get 12.138. I did 30 minus 2D, and I also got 12.138. So that's good news. They both matched. What do you think we would get if we multiplied D times L times W? We better get 2052. So if you really wanted to triple check yourself, you could multiply those and make sure you landed at that volume. Part C, what is the maximum possible volume? Oh, we already found that. Yeah, we already found that. Yes, I suppose we should be careful. All of this is in inches. So depth and length and width are in inches. Volume would be in inches cubed. Number 4. A grain silo is shaped like a cylinder with a cone-shaped top. Cylinder with a cone on top. The radius of the cone is the same as the height of the cone. Drawing not to scale, right? The radius of the cone is the same as the height of the cone. The cylinder is 30 feet tall. Oh, be careful. I was about to label this H, but I already have an H, so maybe I'll just label it 30. 30 feet tall. The volume is 1152 pi. Find the radius of the silo, which presumably is the same thing as the radius of the cylinder. It would be funny to have a bigger cone on top of a smaller cylinder. That would look... I don't think that would be a grain silo. Right, if you had that look. I don't think that's what's going on here. Let's see. So I need the total volume to equal 1152. 1152 pi. Okay, so what are the two things that make up the volume?
The volume of the cone and the volume of the cylinder.
So cone plus cylinder needs to equal 1152 pi. All right, slow down. You're not going to be able to jump to a final equation on these. You're going to have to kind of work through and write out what you're thinking. So the total volume is 1152. That's made up of the cone and the cylinder. It gives me the cone, although I can make one replacement here. What do I know about R and H? They're equal. So we can replace H with R or R with H.
Just say R cubed.
Let's just say R cubed, because H is the same thing as R. So 1/3 pi R cubed is the volume of that cone. Now we need the volume of the cylinder. Do you remember how to get the volume of a cylinder? Pi r squared H, because pi r squared would be the area of the base, the area of that circle, and then if you multiplied by H, then you would extend that up and create a volume. So pi r squared, we said H, but we know H.
30.
We know H for the cylinder anyway. 30. Equals 1152 pi. Well, we do want to put that in the calculator, but I think there's at least one minor thing we could do before we go to the calculator. Divide by pi. That'd make life a little easier. So 1/3 r cubed plus 30 r squared equals 1152. All right, is there?
Oh shoot.
What do you want to do to put that in the calculator? I guess.
Subtract every.
Yeah, I'd move the 1152 over. I suppose if the 1/3 bother you, you can multiply through by 3, but then you get bigger numbers, 90 and whatever that is. But 1/3 is not bad, so I think I just leave it there. 1/3 r cubed plus 30 r squared minus 1152 equals 0. So all of that will go in for y1, and we'll look for the zeros. How many zeros will there be before I even go to the calculator? 3. But I don't necessarily know that there's 3 real zeros, so I don't know. Let's see, x cubed over 3 plus 30x squared minus 1152. Oh, I'm on a weird scale, so I don't know if this is a good idea or not, but let's see. So I don't need my y max to go to 2500. That's a little bit ridiculous. Maybe 100. Maybe that's good enough. Maybe it would have been better to see it the other way. But there's my 0. So there's my r value. Second calc 0. I don't know if I'll be able to find it here. I'm looking at my y values as I'm scrolling around trying to find. Oh, there it went. So I can't quite see it, but I can still do this. There's my left bound. Well, that's to the right. So if I go left one spot, now I'm at a left bound. Press enter. Right bound. Guess. And yeah, I should have checked the table first because r equals 6. Now, is that what the question was asking, though? Because maybe it was asking for volume or... Yep, find the radius of the silo. So we found it. Yeah. And I guess let's put the units on that. 6 feet. All right, number 5. Last one for me. Farmer wants to build 2 rectangular pens of the same size next to a river so that they are separated by one fence. She has 240 meters of fencing and does not fence the side next to the river. This is another classic calculus problem here. So there's my river. I don't need to fence along the river, but I do need 2 pins along the river for whatever reason. Of the same size. Okay, write a function to represent the area of the enclosed. Well, I don't know about a of x yet. Let's just start with area is length times width. Length times width. I'm going to call this length. And that width. Now I've got length times width. But there's a relationship there between L and W. Because what else do I know? It's a rectangle.
It's a square, isn't it?
Yeah, 240 meters of fencing. So what adds up to 240 meters of fencing?
3 lengths plus 2.
3L plus W. Be careful, some people would do these pins separately and call that W and W, and so they'd have 3L plus 2W, which is fine. but we're going to say 3L plus W equals 240. So that means W, I mean I can solve for L or W, but W seems like a better choice here. It's 240 minus 3L. So I can replace W with 240 minus 3L. And now that's not A of X, but it's A of L, meaning there's only one variable. So now I can go to the calculator. Right? I can let X equal the length. So when I go to the calculator, what are the dimensions of the largest area? So what am I looking for? The biggest solution, the peak. So X 240 minus 3X. And my scale is all messed up now, so who knows? Oh, this is big. So L might be way bigger than 20. So I'll go out to 50. It certainly won't be bigger than 240. So maybe I should go 100. I don't know. And that area is probably bigger than 100. So maybe 1,000. I don't know. I'm just kind of guessing. Okay, there we go. I've got the start of a peak there. I need to go up way higher. So my Y needs to go 10,000, maybe? Yeah, there we go. So I found the peak. Second calc maximum. Left bound, right bound. Careful with the peaks. Make sure you get wide enough so that you definitely have the peak in there. X equals 40, and X was L, so L is 40, and the area is 4,800. So we just found the largest area. What are the dimensions? 40 is L. 40 by whatever W 240 minus 3L is. So 120, 240 minus 120 is 120. So 40. I mean, I don't need to do this, but maybe this helps me kind of visualize that, yes, that uses 240 meters of fencing, and that maximizes the area we could enclose. Meters squared. Meters. Okay. All these problems are slightly different, so you need to try some of them. Some of the ones coming up are similar to things that we did, so I think you've seen enough that you'll be able to fight through the rest of them. So your job is 6 through 12. And then tomorrow we'll have time to go over some more of those. So give those a try. Set them up. Use the calculator. See if you can fight through and figure out what's going on. And then we'll look at them tomorrow.